Space debris has become one of the biggest and most alarming problems for the future of space exploration. What once started as isolated incidents of defunct satellites and spent rocket stages has now snowballed into a full-blown orbital crisis. Thousands of non-functional objects are floating around our planet, threatening not just space stations and astronauts, but also the success of future missions to the Moon and Mars. This growing cloud of junk isn't just science fiction, it's a very real danger that engineers, scientists, and even global leaders are beginning to worry about seriously. In recent years, the space industry has seen an aggressive boom. Private companies and national agencies have launched more missions, more satellites, and more technologies than ever before. According to Nobu Okada, the founder and CEO of Astroscale, a company working to clean up space, this new space race is pushing Earth's orbit toward chaos. Speaking at the World Economic Forum in Tianjin, China, he explained how the number of space ventures has exploded. In just the past 5 to 7 years, the world has witnessed the birth of over 2,000 new space startups. And these are not small plans. Many of these companies are preparing to launch thousands, yes, thousands of satellites over the coming decade. Okada estimates that between 10,000 and 20,000 new satellites could be launched in just the next 5 to 10 years. That's an unprecedented rate of activity. While it's exciting for technology and global communication, it also means the number of orbiting objects is growing at an uncontrollable pace. The problem lies in the fact that almost every launch leaves behind some debris, whether it's rocket boosters that detach after launching or satellites that have reached the end of their lifespan. Space is slowly turning into a cosmic junkyard. NASA estimates that over 500,000 pieces of space junk are currently orbiting the Earth. These include everything from old, broken satellites and rocket parts to nuts and bolts that have come loose from past missions. You might think such small objects aren't dangerous, but when you're traveling at speeds of up to 28,000 kilometers per hour, even a tiny screw can cause catastrophic damage, and the numbers only get more terrifying. According to the European Space Agency, as of January 2018, there were about 29,000 objects in orbit larger than 10 centimeters. That's about the size of a small watermelon. But that's just the beginning. There are roughly 750,000 objects between 1 centimeter and 10 centimeters in size. Imagine how much damage a flying chunk of metal the size of a coin can do at hypersonic speeds. Even worse, the number of tiny fragments ranging from 1 millimeter to 1 centimeter has reached a mind-blowing 166 million. That's 166 million high-speed projectiles circling our planet. This isn't just a matter of clutter. Space debris can and has caused real accidents. In 2009, a defunct Russian satellite crashed into an active American commercial satellite, causing both to explode and creating thousands more fragments of debris. Each of those fragments became a new threat to other satellites and missions. The more this happens, the more dangerous space becomes. Experts warn of a possible scenario called the Kessler Syndrome. It's a situation where the amount of space junk becomes so high that one collision triggers a chain reaction of more collisions. This would make certain orbits unusable for generations. Imagine losing the ability to launch communication satellites or conduct Earth observation missions because of the debris left behind by previous generations. Astronauts aboard the International Space Station already have to occasionally maneuver the ISS to avoid debris. It's not an uncommon practice. Every year, the station changes its path slightly to avoid crashing into high-risk objects. Even a small miscalculation could be fatal. It's like trying to drive a car at 100 mph through a junkyard, blindfolded. The stakes are just that high. And as the number of missions increases, so does the frequency of close calls. And now, with major space agencies like NASA, ESA, and even private companies like SpaceX and Blue Origin planning to go back to the moon and eventually reach Mars, the danger is even more severe. Sending humans deeper into space requires them to pass through this debris zone. If the risk becomes too high, some of these bold missions could be delayed or even cancelled. It would be a tragic irony if our ambitions for the future are grounded by the trash we've left behind in the past. Some companies are now stepping up with solutions. Astroscale, for example, is developing spacecraft designed to capture and remove space junk from orbit. Using magnets, robotic arms, and even harpoons, different technologies are being tested to clean up the mess. But it's not an easy task. Space is vast, and tracking small objects is incredibly difficult. Moreover, there's the issue of funding. Cleaning up space doesn't make a direct profit, so many companies hesitate to invest in it. Governments, however, are beginning to recognize the urgency and are starting to enforce stricter regulations on satellite launches and debris mitigation. The solution may lie in creating a shared responsibility model where all satellite operators contribute to a global space cleanup fund. Some experts also suggest designing future satellites with built-in systems to deorbit themselves once their mission ends. This way, they burn up harmlessly in the atmosphere rather than becoming another floating threat. If we fail to act now, we might find ourselves locked out of space altogether. Just like pollution on Earth damaged our oceans and atmosphere, space pollution could shut down one of the most promising frontiers of human progress. We're standing at a critical moment. The choices we make today, how we build, launch, and dispose of satellites, will shape the future of space travel for generations. It's time we stop treating space like a dumping ground and start respecting it as the fragile environment that it is. After all, the stars may be infinite, but the paths to reach them are not.